Hi there, today we're going to have a look at capacitors, or a capacitor. What I want to do is take this apart. What I was thinking of was getting some materials together and try and make my own capacitor. You know, I can't be bothered to do that, so I'm just going to tear this one apart instead and see what's inside a real capacitor. So let's have a look. So here we have a capacitor that I'm going to take apart, see what's inside it. This one is out of a power supply, a switch mode power supply unit, and I'm never going to use it. It's a 200 volt 560 microfarad. I don't know what its status is. Let's just do that as well, just in case there's any charge in there. I doubt that there is, but I want to be sure. Don't want to get out. No, there's no charge in there. But I want to see how they're constructed. I was thinking of making a capacitor, but no, I've decided I'm not going to do that. I'm going to see what's inside a real capacitor. Obviously I've got to get in it, so there goes for the fun of getting into a capacitor. I put some gloves on as well because I've no idea whether it's going to be gooey or not, so I've got to get this outer coating off first. Looks like it's going to be a right bugger. Well, right, come on. Hopefully I can do this without stabbing myself and ending up with blood everywhere. So first and foremost, as you can see, it's like a it's a metal can. It literally is a metal can. So how am I going to get in that? Let's get some snips in here. I'm probably going to wreck these. But hey, let's give it a go. See if I can get under this rubbery stuff. But doesn't want to yield. Oh man. Well, let's see if I can zoom in a bit more. Get more detail on there. Yep, this is that. If I can cut that with the scalpel. Yeah, going in, but how on earth am I meant to get into this? Right, might have to go away and do this and see what I can get out of it and how far I get. But so I might have to go off and do that and come back. Okay, so here we go. And you can see I managed to tear the top off the can, and this is the capacitor. That is the two films of conductive plate together with a dielectric between them. Take off this big rubber stopper at the end there, and there's a little bit of tape on there. Looks like it's holding it in together. If I can get that undone. There we go. And now, as you can see, it's slightly got a slight oiliness. That's why I put gloves on, because there is in an electrolytic there is a liquid of some sort. I suppose I ought to read up and find out what that is. As you can see, it's all sort of unravelling now. It's not tight anymore. I don't suppose I'll get that back in there. Nope. I'm certainly not going to power it up now. But as we can see, if we can get and unravel this, there you go. We've got absolutely marvellous. Look at that. That looks like it's the one plate there, and that there is the other, and that in between being our insulative layer. It's almost like a waxy paper, and that being a metal sheet, and that's the other layer, that's the other metal sheet with our insulative layer. Now there are obviously two different metals, because this one, I don't know if you can hear that, it's almost like a tin foil, yeah, like you wrap your chicken in on a Sunday dinner. Whereas this one is different, and I don't know what that metal is. So we've got two different metals. Insulator there, metal. I suppose got the insulator on the back because when you roll it round to roll it up, it's not going to short out, so it stays insulated. And then you've got the other insulator, and then the other metal. I think that they're called electrolytics because the way that one of the plates, like this one might be, is that they use a process of electrolysis, is it, to make the metal plate, as it were, and in doing so means that the connectors have to be it has to be connected in a particular polarity to ensure that it conducts correctly. Whereas ordinary capacitors are not. Let's find the ends. There's the end of one. Lots of insulated material there. So this is messy. See if I can just zoom out a little bit. What we end up with, if we can do it, is a strip of one metal with a connector there for its terminator, and I suppose I should have looked to find out which terminal was which. Shouldn't I? But I didn't, so I don't know if that's positive or negative. With the metal sheet with its film on, and this is the other metal, a different metal with its sheet. I see it wants to curl up because they were rolled together, and so as you can see, they literally are, as it shows when you see a diagram. There's my pen gone. You literally have, let's get that mess out of the way, a plate, I'll draw it in like that, and then another plate. That in the middle is your dielectric, that's your insulative layer, and two connectors. So you've got your one like it is in this one, like an aluminium sheet, and then this one is the other sheet of some other material, and your dielectric insulator in between. So as you can see, it really is that. It really is two strips of metal with an insulative layer wrapped round together to form a large surface area, put into a can, and sold to you with a specific rating on. Now obviously the manufacturers know how much material they've got to use and what the specs are of the qualities of the dielectric and the metal surfaces to get the right rating and the right voltage rating and the capacitors on there. But other than that, that is really all that a capacitor is. And what I've got is not a capacitor anymore, but a big gooey mess. So I suppose I better get it tidy up, hadn't I? There you go. A capacitor, electrolytic capacitor in this case. So there you go. That's electrolytic capacitor taken apart in bits now. But it's nothing more than two plates, two metal strips in this case, with a insulated material in between, dielectric, and put into a can. Very simple things, nothing more to it than that really. So if you like this video, subscribe, all comments welcome, and I'll catch you next time.